Are you struggling with throttling issues when using Azure Functions with a service bus? You're not alone. Today, we're diving into how to manage downstream system overloads and keep your Azure Functions running smoothly. I completely understand how frustrating it can be when your downstream system is overloaded or returning rate limit headers. It can feel like you're at the mercy of external systems, and that's a common concern for many developers. Let's look at a specific scenario. One user asked about throttling their Azure function when the downstream API is slow or overloaded. They mentioned that while they can set max concurrency, they still lack control over the downstream system's performance. Sound familiar? Let's explore some solutions. So, what's the issue here? When the downstream system is overwhelmed, it can lead to failed requests or throttling. Understanding how to manage this effectively is crucial for maintaining a smooth workflow. Stick around. I'll share some practical strategies to handle these throttling issues, and trust me, you won't want to miss the final tip that could change how you manage your Azure functions. To begin addressing the user's concern about throttling the service bus triggering, we can implement a multi-queue strategy. First, the user should set up 3 queues: Q1, Q2, and Q3. In Q1, the user should process messages at full speed. If the downstream system starts to return rate limits, the user can set a cache value to indicate this condition. If the cache value is set, the user should not process the message in Q1. Instead, they should clone the message and place it into Q2 for slower processing. Q2 will have a lower maximum concurrency and prefetch count. If the downstream system is still saturated, the user can repeat this process by pushing messages into Q3. Finally, Q3 will process messages at the slowest rate. This setup allows the user to control the flow of messages based on the downstream system's capacity. Fun fact, did you know that Azure Functions can scale to handle thousands of requests per second? But with great power comes great responsibility, especially when managing downstream systems. Now, let's look at the answers provided by other users. This user points out that back pressure features are not currently available with the service bus trigger in Azure Functions. They suggest that you will need to manage this yourself. The approach you've outlined can work, but it requires handling different function apps, since service bus settings apply to the entire app, not individual functions. Additionally, for the apps managing queues 2 and 3, they recommend using a preview flag called Website Max Dynamic Application Scale Out to limit the number of scaled out instances. However, this feature is still in preview and may not be reliable. Finally, they encourage you to open an issue on the Azure Functions GitHub repository to document your scenario, as feedback is valuable for addressing these types of issues. That's it for that answer. Let's take a look at another one. An alternative approach suggested by another user is to ask your downstream team to provide a queue endpoint alongside the regular API endpoint. This way, you can send messages to their queue, allowing them to process the requests at their own pace. Here's a pro tip. Regularly check and update your host settings to adapt to changing rate limits. This can help you manage throttling dynamically and keep your functions running smoothly. And there you have it. With these strategies, you can effectively manage throttling in your Azure Functions. If you found this video helpful, don't forget to subscribe for more tips and tricks on optimizing your cloud solutions.